Point at any patch of black between the stars and keep pointing outward forever. In an infinite universe packed with stars, your finger has to land on the surface of one, eventually. Every direction should end in blinding light. So why is your finger pointing at nothing? Here's the part that should keep you up tonight. That darkness overhead is a clue. It's telling you something about how the universe began. And once you see it, you can never look at a night sky the same way again. Let's make the problem sharp. Imagine you're standing in an infinite forest. Trees in every direction, forever. Look straight ahead. Your line of sight might slip past the first tree and the second, but keep going far enough, and eventually it has to hit bark. There's no gap you can look through to escape the forest. It's trees all the way out. Now, swap the trees for stars. If the universe is endless and old and unchanging, the same thing has to be true. Every single line you could look along ends on a star. Not most of them, all of them, which means the whole sky should glow. Not a little. It should blaze as bright as the surface of the sun. Point in any direction, and you'd be staring into fire. The night wouldn't just be bright, it would cook you alive. But it doesn't. You can walk outside right now and look up into cold, quiet dark. That contradiction has a name. It's called Olber's paradox, and it stumped some of the smartest people who ever lived. Now, you might be thinking you've already solved it. The stars are just really far away, right? Their light gets dim, so the sky stays dark. That's the trap, and here's why it fails. Yes, a star twice as far away looks 4 times fainter. But think about a shell of sky twice as far out. It's a bigger shell. It holds 4 times as many stars. The dimming and the crowding cancel out. Exactly. Every shell of the sky, near or far, sends you the same total glow. Stack up infinite shells and you get infinite brightness. Distance doesn't save you. So people reached for another answer. Maybe there's dust out there. Clouds of gas blocking the light. That was an early favorite. It fails too. In an endless, ancient universe, that dust would sit there soaking up starlight for eternity. Soak up enough and it heats up. Heat it enough and it starts to glow. Give it forever and the dust shines as bright as the stars it was supposed to hide. You can't hide light forever. It always wins. So the real answer isn't distance. It isn't dust. It's something stranger. The universe had a beginning. And a man famous for writing about ravens saw it first. Edgar Allan Poe. In 1848, in a strange prose poem called Eureka, Poe wrote that if the stars went on forever, the whole sky would be a wall of light. The reason we see gaps, he said, is that the distant background is so far away that no ray from it has reached us yet. A poet, decades before the physics existed, put his finger on it. Light has a speed, and time has a start. Here's what that means for you standing outside. When you look far away, you're also looking far back in time. The sun you see is 8 minutes old. The nearest star beyond it, about 4 years. Look deep enough and you're seeing light that left before there were people. Keep going. Eventually, you reach a distance where the light left so long ago that it hasn't finished the trip. It's still out there, crossing space, on its way to your eyes. It hasn't arrived. The universe is about 13.8 billion years old. So, there's a wall. Beyond it, the light simply hasn't had time to get here. Most of the stars in an endless universe are behind that wall. Their light is in the mail, and the night is dark because the delivery isn't done. Between the stars, in any random direction, your line of sight would have to travel unimaginably far before it hit a stellar surface. Far, far more than 13.8 billion light years. So it runs out of time first. It ends in empty, unfilled dark. That dark isn't nothing. It's the light that hasn't shown up yet. Now, maybe you've heard a different answer. The universe is expanding. Distant light stretches out and reddens and fades. And that's true. It's a real effect. It does dim the far-off galaxies. But it's the second reason, not the first. Even if space weren't expanding at all, a universe only 13.8 billion years old would still have a dark sky. The finite age does the heavy lifting. The expansion just helps. And here's the objection you should be forming right now. But if that blazing sky is really out there, waiting behind the wall. Shouldn't we be able to find it? We did. The bright sky Olbers imagined actually exists. We just can't see it with our eyes. As the universe expanded, it stretched the oldest light so far that it dropped out of visible light and into microwaves. It fills the entire sky, every direction. A faint, even hum at about 2.7 degrees above absolute zero. We call it the cosmic microwave background. It's the afterglow of the Big Bang itself, and you have seen it. Older TVs, the analog kind, that snowy static hiss when there's no channel. A small fraction of that snow is this, the literal glow of the young universe landing in your living room. You grew up calling it nothing on. It was the oldest light in existence, so Olbers was right. The whole sky does blaze. It's just been stretched down from fire to a whisper. Now, how faint is the leftover starlight really? In 2021, scientists used a spacecraft called New Horizons, way out past Pluto, far from the dust of the inner solar system that ruins the view from Earth. They measured the true darkness of deep space, the combined light of every star and galaxy that has ever shined at us. And it's astonishingly weak, roughly like a single dim bulb seen from a couple of miles off, smeared across the entire sky. That's all the starlight there is. In the part of the universe we can actually see, the stars are so spread out that most lines of sight just miss them completely and sail off into the dark. So let's go back outside. Back to your finger, pointing at that patch of black. You now know what you're touching. Not empty space. Not the edge of anything. You're pointing at light that is still on its way. Stars that are shining right now, tonight, whose glow left long ago and just hasn't crossed the gap yet. Give the universe enough time, and one by one, those points would fill in. The darkness isn't a lack of stars. It's a clock. Every night you look up, you're reading it. The dark is telling you the universe is young enough and spreading out fast enough that its light is still arriving, still filling in. The night sky is dark for one reason, because it hasn't always been here. And that quiet black between the stars, that's the oldest thing you'll ever see with your naked eyes. The proof, hanging right over your head, that everything had a beginning.